With Panopticon 2022.1, we introduced a new example workbook called How to Python. First, find this workbook in the examples.exz bundle file and import it to a folder on your Panopticon real-time server. The first dashboard in the workbook tells you whether your Python environment is responding, the version of Python you are running, and verifies that you have the required Python package versions installed. If you are missing any of the required packages, or if the version is too old, this dashboard will let you know. The dashboard will show if the package needs an upgrade to a newer version, or if the package is missing in your Python environment. The next dashboard shows you information about your Python environment, including the host operating system and the Python installation path. The Modules dashboard lists all modules and packages you have available in your Python environment. This makes it easy to confirm that all packages you need are installed. The dashboard called Pyro explains how the software is executing Python code via Pyro, and why you always need a return statement at the end of your code. The Pandas dashboard explains the advantage of working with Pandas data frames instead of Python lists and dictionaries. On the Arrows dashboard, we explain the benefits of enabling arrow serialization on your Python transforms and Python data connections. Arrow serialization supports faster data transfers between Panopticon and Python. The Exception dashboard includes an interactive example to help you write code using try-except clauses to handle unexpected errors and exceptions. The Debugging and Troubleshooting dashboard provides some practical advice and examples about structuring your code for easy debugging. It also shows other tools and methods you can use to identify errors in your code quickly. The interactive Random Idea dashboard demonstrates how to enable your dashboard users to control input parameters to your Python code and obtain different results based on that input. The K-means dashboard shows an example of unsupervised machine learning. It applies K-means clustering to a randomized dataset. The dashboard user can dynamically control the properties of the dataset as well as the number of clusters defined. The Logistic Regression dashboard shows a simple example of supervised machine learning in the form of classification with logistic regression on a dataset from the scikit-learn package. The code in this example does feature selection, random train test data splitting, model training, model scoring, and model performance evaluation based on the settings entered by the dashboard user. The Fibonacci Fan dashboard demonstrates how you can use a Python transform to calculate Fibonacci fan lines for historic stock prices. The dashboard includes historic data for a small selection of stocks. By switching on Live Data, you can view any stock ticker you like. Learn how the calculations are done by digging into the example Python code. And finally, the Clock dashboard shows how to apply a Python transform to a dataset several times per second. This is needed when working with streaming data sources that provide frequent updates. In this example, the Python transform is running code that looks at the system time and builds a dataset with columns and rows that allows you to draw a clock using the scatterplot visualization part.